Hi students, in this video we are going to discuss about direct to comparison test or comparison test for improper integrals. Comparison test. Comparison test or direct comparison test. First, write down statement of this comparison test or direct comparison test. After that, we will see what is comparison test for improper integrals, and also after that we will see one example. Okay, first write down statement. So what is the statement? Let f of x and g of x be continuous functions on closed interval a comma infinity with f of x less than or equal to g of x for all x greater than or equal to 2 a. Then first one, integral from a to infinity f of x dx converges if integral a to infinity g of x dx converges. Second one, integral a to infinity g of x dx diverges if integral a to infinity f of x dx diverges. Write down. Okay students, already we discussed comparison test or limit comparison test for series. Here also we will learn about comparison test and limit comparison test for improper integrals. That means in this chapter we will see how to use limit comparison test or comparison test for improper integrals. Here, this is a method of testing for the convergence of improper integral. Okay, in this test, one improper integral will be compared with the second improper integral. That means this test tells us that we will compare one improper integral to another improper integral which is determined convergent or divergent. Okay, so let us consider f of x and g of x be two continuous functions and which are also continuity on closed interval a comma open interval infinity. That means let us consider f of x, g of x be two functions and which are also continuity on closed interval a comma open interval infinity, which satisfies the condition f of x less than or equal to g of x for all x which belongs to closed interval a comma open interval infinity. Okay, So first let us consider f of x and g of x be two continuous functions which are defined on closed interval a comma open interval infinity, which satisfies the condition, that is f of x less than or equal to g of x for all x greater than or equal to a. Then x greater than or equal to a, that's all. If integral from a to infinity g of x dx converges, then integral from a to infinity f of x dx is also converges. Similarly, if integral from a to infinity f of x dx diverges, then integral from a to infinity g of x dx diverges. Okay. So here you can see here, students, f of x less than or equal to g of x. F of x less than or equal to g of x. If integral from a to infinity g of x dx convergent, then we can say that integral from a to infinity f of x dx is also convergent. Similarly, if integral from a to infinity f of x dx diverges, then we can say that integral from a to infinity g of x dx diverges or divergent. Okay, students. Okay. Already we know that comparison test for series. Here also we have to follow same procedure. Don't confuse. Okay, so here we have to follow same procedure. Don't confuse. Okay, students. You can see here, students. Here, what is the bigger function? What is the smaller function? F of x is smaller function. G of x is bigger function. That means if integral of the bigger function is convergent, then we can say that the integral of the smaller function is also convergent. Similarly, if integral of the smaller function is divergent, then we can say that integral of the bigger function is also divergent. Okay, integral of the smaller function is divergent, then we can say that integral of the bigger function is also divergent. We have to follow same procedure. Don't confuse. Okay. Now let us see one example. Okay. Write down. Discuss the convergence of the following I means improper integral from 2 to infinity 1 by ln x dx. Okay. Students, you can see here, can you find this improper integral directly? That means, can you find integral from 2 to infinity 1 by ln x dx directly? No. You cannot find integral from 2 to infinity 1 by ln x dx directly. Okay. For finding this type of improper integral, we must use comparison test or limit comparison test as you like. Okay. For finding this type of improper integral, we must use comparison test. Now, let us see whether the given improper integral is convergent or divergent by using comparison test. So first let us consider the given improper integral has integral of f of x. Okay, let integral from 2 to infinity 1 by ln x dx is equal to integral from 2 to infinity f of x dx. Okay, so first let us consider the given improper integral as improper integral of f of x dx. Okay, therefore f of x will be equal to 1 by ln x. Okay, 1 by ln x. Okay, clear? Now let us see how to use comparison test for this improper integral. Okay, so here we have to follow same procedure. Okay, whenever you are using comparison test in the series. Okay, okay students, already we know that ln x less than x for all x greater than 1. ln x less than x for all x greater than 1. Already we know that this condition. Okay, okay, don't confuse. So here we have to follow same procedure for the series. Ln x less than x, therefore 1 by ln x greater than 1 by x. 1 by ln x greater than 1 by x, therefore 1 by x less than 1 by ln x. Okay, so next we have to apply integral from 2 to infinity on both sides throughout this inequality. By applying integral from 2 to infinity throughout by this inequality, so here we get integral from 2 to infinity 1 by x dx less than integral from 2 to infinity 1 by ln x dx. Okay, okay, for suppose the given integral starting from 1 to infinity, so then we have to apply here integral from 1 to infinity, that's all. Okay, so here I am applying integral from 2 to infinity on both sides of about this inequality, because the given integral from starting from 2 to infinity. Okay, don't write anything. Okay, so here let us consider integral from 2 to infinity g of x dx less than integral from 2 to infinity 1 by ln x is nothing but f of x dx. Okay, this is okay. So this is f of x, this is g of x. Integral of g of x less than integral of f of x. Okay, so next we have to find the value of integral from 2 to infinity g of x dx. That's all, because you cannot find integral 2 to infinity f of x dx. Okay, first we have to find integral from 2 to infinity g of x dx. Okay, integral from 2 to infinity g of x dx, which is equal integral from 2 to infinity g of x is nothing but 1 by x dx, which is the second form of improper integral of first kind. Already we know that how to evaluate second form of improper integral of first kind. Okay students, so now which is equal integral from 2 to infinity 1 by x dx can be written as limit b tends to infinity integral from 2 to infinity 1 by x dx. So now which is equal limit b tends to infinity integral of 1 by x is nothing but ln x. Okay, so here upper limit is infinity, lower limit is 2. So next which is equal limit b tends to infinity, sorry this is b. Okay, this is b, sorry. Okay, right, sorry, this is b. So now ln b minus ln 2. Okay, so next we have to apply limit b tends to infinity. So here we get ln infinity minus ln 2. ln infinity always infinity, remember that point. ln infinity always infinity. Infinity minus something, infinity minus something infinity, infinity plus something infinity. Okay, infinity minus infinity infinity, infinity plus infinity infinity. Okay, which is infinite. Therefore integral from 2 to infinity g of x dx is divergent. But integral from 2 to infinity g of x dx is nothing but smaller function. Okay, already we know that integral of smaller function is divergent, then integral of bigger function is also divergent. Okay, already we know that integral of smaller function is divergent, then integral of bigger function is also divergent. Okay, clear? Okay, write down. So here integral from 2 to infinity g of x dx is nothing but integral from 2 to infinity 1 by x dx divergent. Okay, okay. So here integral from 2 to infinity g of x dx is nothing but smaller function. Integral of smaller function is divergent, then integral of bigger function is also divergent by comparison test. Okay, what is the comparison test? If integral of smaller function is divergent, then we can say that integral of bigger function is also divergent. So what is the bigger function here? What is the integral of bigger function here? Integral from 2 to infinity 1 by ln x dx. Therefore, by CT means by comparison test, we have integral from 2 to infinity 1 by ln x dx is divergent. Okay, because integral from 2 to infinity 1 by ln x dx is integral of bigger function. Okay, write down. Next, write down second problem. Integral from 1 to infinity e power minus x square dx. Integral from 1 to infinity e power minus x square dx. Okay, just listen. So here we have, write down solution, we have e power minus x square always less than e power minus x for all x greater than or equal to 1. E power minus x square less than e power minus x for all x greater than or equal to 1. For verification, you can check for x values. Okay. For any doubt, you can check for x values this condition. Okay. So next, we have to apply improper integral on both sides throughout by this inequality. Okay. So here I am applying improper integral from 1 to infinity throughout by this inequality. So here we get integral from 1 to infinity e power minus x square dx less than integral from 1 to infinity e power minus x dx. Okay, so this is this is small function, this is big function. Okay, so next we have to find this improper integral. That means next we have to find improper integral of or integral of 1 to infinity e power minus x dx. Tell me, integral from 1 to infinity e power minus x dx. Tell me. So here integral from 1 to infinity e power minus x dx can be written as limit b tends to infinity integral from 1 to b e power minus x dx. Tell me, integration of e power minus x by minus 1 is nothing but minus e power minus x. Okay, so lower limit is 1, upper limit is b. So this can be written as limit b tends to infinity minus e power minus b plus e power minus 1. Okay. Okay. So now which is equal to limit b next we have to apply b tends to infinity. So here we get minus e power minus infinity plus e power minus 1. E power minus infinity 0. Therefore e inverse nothing but 1 by e, which is finite. Therefore by comparison test we can say that Therefore, by comparison test, we have integral from 1 to infinity e power minus x square dx is convergent. Okay. Because integral of bigger function is convergent. Okay. Student, okay. So next I will give you some problems. Okay. Write down. Write down. Discuss the converges or diverges of the following improper integrals. First one, integral from 1 to infinity sin square x by x square dx. Sin square x by x square dx. Okay, how to evaluate this improper integral by using comparison test? Okay, so here already we know that sin x lies between minus 1 to 1, but sin square x lies between only 1. Sin x lies between minus 1 to 1, sin square x always less than 1. Okay, okay. So in this case, what is the another function? This is the first function, that is f of x. What is the another function g of x? Tell me. So in this case, g of x will be 1 by x square. Okay, this is convergent. So what is g of x here? So here I will give you g of x. So this is f of x. What is g of x? Okay, what is g of x? Now let us see how to choose another function in this problem. Okay, f of x is equal to sin square x by x square. G of x will be sin square x always less than or equal to 1. Okay, okay, less than or equal to 1 divided by in denominator, what is the highest power of x? What is the highest power of x in denominator? X square. So this is g of x. That's all. So here we have to follow same procedure. Don't confuse. Okay, sin square x always less than or equal to 1, and in denominator what is the highest power of x? X square. Okay, take g of x. Okay, so next we have to check either f of x less than g of x or f of x greater than g of x for x greater than 1, because integral starting from 1 to infinity. Okay, here we have to check either this condition, that means f of x less than g of x or the f of x greater than g of x for x greater than 1 only, not x greater than or equal to 1. Okay, x greater than 1. Suppose integral starting from 2 to infinity, then that situation we have to take x greater than 2 only. Okay. So next we have to find integral from 1 to infinity g of x dx, because the given integral starting from 1 to infinity. Okay, clear? Okay, take only x greater than 1. Okay, this is the condition, because integral starting from 1 to infinity, not x greater than or equal to 1. Remember that point, students. Okay. Okay, so here x belongs to open interval 1 to infinity. That's all. Not closed interval 1 to infinity, open interval. Okay. Okay, students, don't confuse. Next, second one, integral from 1 to infinity 1 by under root of x square minus 1 dx. Okay, this is divergent. Tell me what is g of x here? Tell me what is g of x here? How to choose g of x? So what is the highest power of x in numerator? 1. What is the highest power of x in denominator? Root x square. Root x square is nothing but 1 by x. Okay, therefore g of x will be equal to 1 by x in this case. Okay, clear? So next we have to evaluate integral from 1 to infinity 1 by x dx only, because the given integral starting from 1 to infinity. Okay. Next, third one, integral from 1 to infinity x plus 4 by x power 3 by 2 dx. Okay, this is divergent. So here this is divergent. Okay, find in this case g of x. Okay. Next, fourth one, integral from 2 to infinity 1 by x square plus 2x dx. Okay, this is convergent. This is convergent. Next, fifth one, integral from 3 to infinity 1 by x minus e power minus x dx. Okay, integral from 3 to infinity 1 by x minus e power minus x. This is divergent. Okay, tell me what is g of x here? What is g of x here? So here I will give you g of x, don't worry. So here what is the highest power of x in numerator? 1. What is the highest power of x in denominator? So here in denominator we have two functions, x and e power minus x. What is the highest power of x in denominator? Only x. Okay, please check it. Sixth one, integral from 1 to infinity x by under root of 1 plus x power 4 dx. Okay, this is divergent. Next, seventh one, very important seventh one, integral from 1 to infinity x plus cos x divided by x cube plus x square dx. Okay, this is convergent. What is the function g of x? Tell me, students. So what is the highest power of x in numerator? Okay, so in numerator we have two functions, x and cos x. What is the highest power of x? So here the highest power of x in numerator is ax, because cos x always lies between minus 1 to 1 or cos x less than or equal to 1. Okay, clear? X. Now what is the highest power of x in denominator? X cube is nothing but 1 by x square. This is g of x. Okay, cos x always less than or equal to 1. Okay. Eighth one, integral from 0 to infinity 3 by e power x plus x dx. Okay, this is convergent. Okay, so here what is the function g of x? 3 by e power x. Okay, 3 by e power x. Do it. Ninth one, 0 to infinity sine square x by e power x plus 1 dx. Okay, this is convergent. Okay, what is g of x here? Tell me. Sine square always less than or equal to 1. Okay, by what is the highest power of x in denominator? E power x. Okay, do it. 10th one, integral from 2 to infinity ln x by e power x plus 1 dx. Okay, this is convergent. Okay, what is g of x here? Tell me. What is g of x here? Tell me. Tell me. So here ln x always less than x. Ln x always less than x. By what is the highest power of x in denominator? E power x. Do it. Ln x always less than x. That's why I am taking x in numerator. Divided by what is the highest power of x in denominator? E power x. That's all. Don't confuse. Please do it all these problems, students. Okay.